Okay, so when you're looking at quotients, there's a couple of options that can happen, but you need to also be aware that when we differentiated the natural log of a function, we actually ended up going to the function's derivative over the function. So if we're integrating, we want to go this way. If you ever see that there's a function that's derivative is divided by the function, you're quite simply can use the natural log. Okay, so this first one, 2x is x squared differentiated. So this is just going to be natural log of x squared plus 8. Okay, plus c. Now, the only problem that you have there is that obviously, again, that function above was defined for all values of x, so we want to use the absolute values of x squared plus 8. Here, not so much of an issue because x squared is always positive, and if you add 8, it's still going to be positive, but it's useful to leave that in. Okay, so see, this function in the inside, this x squared plus 8, if I differentiated it, I'd get that 2x. Okay, so if you want to generalize this, if you've got a power, say this x squared down here, on the bottom, and that's going to be less than one greater than the power at the top, this x squared, quite often that's something that you're looking for, because if that's the situation, that bottom function, if I differentiated it, is usually going to give you the top function. Let's look at this. If I differentiated x cubed plus x squared, I'm going to get 3x squared plus 2x. Now, that top function is twice that, so I'm expecting my answer to be twice the natural log of the absolute value of x cubed plus x squared plus c. So quite often this 2, that quite often you're going to need to have a number in front that as a multiplying factor just to correct it up. Okay. Now, this same logic, if the function on the bottom differentiates to give you the function on the top, it's always going to be it. So here, sorry, wrong colour. Here we've got natural log of the absolute value of e to the x plus 2 plus 7. Yeah, because if I differentiated e to the x plus 2 plus 7, I would get the numerator, which is e to the x plus 2. Okay, so the same thing is happening there. Okay, this next one, which is going to be a bit more aware of it. Now, if I differentiated sine, I would sine 2x. Okay, if we actually differentiated sine 2x, I would go to 2 cos 2x, wouldn't I? Now, that's not what I got. I'm out by a factor of 2. So I'm 2 more than what I want, so I want to half it. Natural log of sine 2x. So you can see, again, if I differentiate the bottom and I get the top, I use the natural log. However, quite often you'll need to have that multiplying factor, that half or that 2, to correct it, because otherwise you end up being in the situation where it's not actually equivalent. Okay, so you need that multiplying factor.